Hello and welcome back to the course. In this module, we're going to study the analysis of evidence. Digital information and evidences taken from a computer are used to aid in an investigation. While computer forensics was originally limited largely to online fraud and hacking, today it serves a powerful investigative tool for a number of crimes including theft, murder, harassment, abuse, and rape. Proper digital forensics and incident response analysis is essential to successfully solve today's complex cases. Each analyst should examine the artifacts and then analyze the activity that they describe to determine a clear picture of which user was involved, what the user was doing, when the user was doing it, why and how, which can describe the point of entry or vulnerabilities exploited. Investigators might review deleted files, communications, and images to track criminal activity. They will likely also analyze online search history and social media activity. Just about everything we do online leaves a trace, and the best investigators can follow it. Once the relevant material is saved, it is then duplicated. The material may not be modified in any way and must be properly stored. Once an exact match is made, the material is analyzed. So, what should we look for? Internet history is a good location to find data. People leave behind a large digital footprint online, and this includes the website they have visited. Profiles on online dating websites may indicate adultery in a divorce case. Searches for poisonous cocktails could point to murder. This history may also be helpful in establishing a motive. Emails are an extremely powerful tool. As hard as we may try, it is quite difficult to erase an email completely. Messages might be analyzed to prove criminal behavior, such as tax fraud or drug dealing. Although less common, it is possible to send a text message from your computer. These messages often contain intimate, revealing material that may be pertinent to a civil or criminal case. You might be wondering what makes social media such a powerful source on computer forensics. The answer is that photos, messages, likes, and posts intersect for a powerhouse of intimate information. Files and images are important. Even if you use your smartphone most of the time, you probably have a number of documents and images on your computer. You may even store data from your smartphone on your computer as a means of backup. So, where to look? For the email attachments, the email industry estimates that 80% of email data is stored via attachments. Email standards only allow text. Attachments must be encoded. On Windows XP, we can find Outlook files in the User Profile folder in the Local Settings, Application Data, Microsoft Outlook. For Windows 7 and higher, the location changed to the User Profile, App Data, Local, Microsoft Outlook. Microsoft Outlook data files found in these locations include OST and PST files. One should also check the OLK and content. The Outlook folder might change depending on the specific version of Outlook used. Skype history keeps a log of chat sessions and files transferred from one machine to another. This is turned on by default in Skype installations. In Windows XP, we can find these files under the C disk, Documents and Settings, Username, Application, and Skype, and in Windows 7 and higher, we can find it under the User Profile, App Data, Roaming, Skype. Each entry will have a date or time value and a Skype name associated with the action. Firefox and Internet Explorer have a built-in download manager application which keeps a history of every file downloaded by the user. This browser artifact can provide excellent information about what sites a user has been visiting and what kinds of files they have been downloading from them. We can see in the screen the location where these files are saved for Firefox and Internet Explorer. For program execution and file folder opening, this Open Save most recently used key tracks files that have been opened or saved within a Windows Shell dialog box. This happens to be a big dataset, not only including web browsers like Internet Explorer and Firefox, but also a majority of commonly used applications. On both Windows XP and Windows 7 and higher versions, the location of this file is the same, under ntuser.dat. The last visited MRU tracks the specific executable used by an application to open the files documented in the OpenSafe MRU key. In addition, each value also tracks the directory location for the last file that was accessed by that application. The location of this key changed from Windows XP to Windows 7, and the name also changes from last visited MRU to last visited PIDL MRU. The recent files is a registry key that will track the last files and folders opened and is used to populate the data in recent menus of the Start menu. This key will track the overall order of the last 150 files or folders opened. MRU list will keep track of the temporal order in which file or folder was opened. The last entry and modification time of this key will be the time and location of the last file of a specific extension was opened. Microsoft Office programs will track their own recent files to make it easier for users to remember the last file they were editing. The location is under the ntuser.dat software Microsoft Office, and the version will change depending on the Office version. Similar to recent files, the last entry added will be the time the last file was opened by a specific Microsoft Office application. Here's a quick question for you. Which key tracks files that have been opened or saved within a Windows Shell dialog box? Is it A. Last visited MRU, or B. Recent files, or C. Open Save MRU, or D. Skype history? If you said C, you are right. Open or Save MRU tracks files that have been opened or saved within a Windows Shell dialog box. So we have analyzed some key locations of the operating system, where we as a forensic analyst should look to find evidence. In the next module, we are going to study another key named User Assist that can be helpful in an investigation. I strongly recommend revising the references and supplementary material of the module to get a deep understanding of these keys. Hi, welcome back! We have discussed how to find evidence in Windows. In this video, we're going to analyze another important key. Microsoft Windows operating systems implements various login and error reporting mechanisms to have a record of how the system is being used. This information is logged at numerous hidden locations on a hard drive to make the operating system more interactive and user-friendly. These logs can serve as a forensic nugget to analysts to exploit. The User Assist key, a part of the Windows Registry, was first introduced in Windows NT 4 and continued in later versions of Windows, including Windows 10. The User Assist key is a very useful resource in the area of program execution analysis to analyze what programs were recently run and their execution history. The information obtained from User Assist key can also be leveraged in construction of forensic timeline of user activities. The evidence of running programs on a Windows system can be found in numerous log files including prefetch, page file, event logs, NTFS USN journal, registry keys, jump list, among others. The User Assist key is maintained by Microsoft in each user's ntuser.dat, which is a hide file at the following file path: software, Microsoft Windows, current version, Explorer, User Assist, for all versions of Windows, or on a live computer system at HKCU, software, Microsoft, Windows, current version, Explorer, User Assist. Beneath the User Assist key, there are at least two subkeys, which are the same across platforms but may be more in different versions of Windows. Such keys represent globally unique identifiers, and each identifier key contains a subkey called count, under which the actual values are stored in an obfuscated manner. Some researchers have identified that these values are encoded with the ROTS 13 encryption algorithm, which is a substitution cipher that replaces a letter with the 13th letter after it. In Windows XP and Vista, User Assist keys binary data contains information for the applications launched by a user only via Windows Explorer. The most significant change of User Assist keys in Windows 7 was a new format of binary data. In Windows 7, the size of the binary data was 72 bytes as opposed to 16 bytes in Windows XP and Vista. This structure appears to be the same in more recent versions of Windows. In modern Windows, the user assist key also keeps track of applications and how they were launched. The first 4 bytes identifies a session that appears to vary across same platform. The next 4 bytes, starting at offset 4, represents a counter that increments upon program execution. This attribute can supply background information on the frequency with the applications have been executed in the system. On a Windows XP or Vista machine, the run count starts with the number 5 as default value. Therefore, if the counter displays a 6, then the application has only been run one time. If the user assist key gets cleared, then the hex counter value will start over at 5. The last 8 bytes is the time stamped in UTC format. With this information, one can see what program was launched, when it was launched, and how many times it was launched. The new structure can reveal the focus time in milliseconds that an application had. This can provide information of how long a program was being executed on the system by a particular user. The last execution timestamp in file type, when decoded, can provide the date and time when the application was last time executed. Okay, here's a quick question for you. For the user assist key on a Windows XP or Vista machine, if the run count displays a 6, then how many times the application has been run? Do you think it's A, 1 time, or B, 2 times, or maybe C, 5 times, or D, 6 times? If you said A, you are correct. On a Windows XP or Vista, the run count starts with the number 5 as a default value. Therefore, if the counter displays a 6, the application has only been run one time. We have analyzed the user assist key. There are publicly available scripts and GUI tools to parse this key. In the next video, we will be analyzing some of them. And as usual, don't forget to check the references and supplementary material for more information on the user assist key. Hi, welcome back to the course. In this module, we have explained the user assist key, a part of Microsoft Windows Registry that records the information related to programs run by a user on a Windows system. As analyzed before, program execution analysis is very important for forensic and malware analysts. The user assist key can provide significant information regarding suspect activity, such as which programs are consistently used, evidence of uninstalled programs, evidence of a file existence, and so on. There are publicly available script and GUI tools to parse the user assist key of a live system. All of these utilities have the same functionality. They decrypt and display the list of all user assist entries stored under the HKey current user, software, Microsoft Windows, current version, Explorer, user assist key in the registry. The user assist key contains information about the exe files and links that are opened frequently. The tools usually display a table of programs executed on the Windows machine, complete with running count and last execution date and time. Some of them will allow you to save the list of user assist entries into different format files such as text, HTML, XML, or CSV, as well as manipulate or delete these entries. There are many tools to parse the user assist key, such as User Assist View by Near Software, which is a freeware and doesn't require any installation process or additional DLL files. The use is pretty straightforward. The user just has to click on the executable file and it will display the list of all user assist items stored in the registry. The user then can select one or more items and save them to a file or delete them. User Assist Utility by Didier Stevens, it is also easy to use. Just by clicking an executable file, the user will be able to see and manipulate the user assist entries. In addition to showing the entries in the local registry, it has the option to load the information from a reg file. Magnet Forensics tools will parse the user assist registry data and decode the ROT13 encoded data, providing examiners with the file name and path, application run count, associated user, and the date and time when the program was last executed. Depending on how the program was executed, Magnet Forensics tools may report either the path or a globally unique identifier path combination for a given entry. The path entries are straightforward and help indicate where a program or link was executed from, but the globally unique identifier requires some interpretation. These globally unique identifiers represent common paths on the system, such as a user's app data folder, system32, or other locations that are commonly mapped. Magnet Forensics tools do not map these identifiers for the examiner. Okay, before finishing, here's a quick question for you. What is the cipher used to encode key names associated to user assist? Is it A, ROT13, or B, ROT5, or C, ROT47, or D, ROT17? If you said A, you are correct. ROT13 is a monoalphabetic substitution cipher that replaces a letter with the 13th letter after it. In this module, we have analyzed some general registry info to look for when analyzing the evidence. We studied the user assist key, its structure and importance, as well as some tools to parse it. Don't forget to check the references and supplementary material for more information. And in the next module, we are going to analyze another of the Windows Forensic Essentials, the Windows Prefetch, the definition, how it is populated, and the variations in the different versions of Windows. Hi, welcome back to the course. In this module, we're going to study another of the Windows Forensic Essential, the Windows Prefetch, which is a directory that contains files that help increase the efficiency of the system. We will see what it is, the structure, the configuration in the registry, and how is the prefetching process performed. Windows Prefetch files first appeared in Windows XP, and their purpose is to boost the startup process of launch applications. They include the name of the executable, which they accelerate, Unicode of the DLLs that the executable requires to function, timestamps which pinpoint when the application was last launched, and a counter that keeps track of the times that the executable has been executed. Prefetch files can reveal that an application was actually installed and launched by the suspect at some point in time, even if they unveil the presence of a wiping application or evidence eliminators and nothing else, which are programs with the purpose of thoroughly removing selections of data from the hard drive. That's because the actual evidence was destroyed by the wiping application. The mere presence of a wiping application can itself become as incriminatory as the files that were destroyed with it. Prefetch file names have the following naming convention. Executable name, as it is stated, is the name of the executable file. Hash is an 8-character hexadecimal hash of the path from which the executable was launched, and .pf is the file extension. Note that a dash separates the executable name from the hash and that the file name is made up of only uppercase characters with the exception of the file extension. Then, when an application is started from a different or separate location on the drive, multiple distinct prefetch files will be created, each corresponding to one of the locations from which the application was run. Prefetching also exists in Windows Vista, where it has been enhanced by Superfetch, ReadyBoost, and ReadyBoot. Superfetch logs usage scenarios and places resources into the memory before they are requested. ReadyBoost is a disk cache which boosts processes by using any type of portable flash mass storage system as a cache, which enables the operating system to service random disk reads with enhanced performance. Ready-boost caching doesn't only relate to the page file or system DLLs, but to the whole disk content. Prefetching takes place when the operating system is monitoring components of data that is extracted from the hard drive into the RAM. The monitoring takes place on three scenarios. First, it begins on every system startup and lasts for 2 minutes of the boot process. Second, it also takes place following the completion of the startup of all Win32 services and lasts for 60 seconds. Finally, it occurs each time an application is launched and lasts for the first 10 seconds of its execution. Subsequently, the cache manager along with the task scheduler writes the data into .pf files. These files speed up the system by making themselves promptly available before there is any actual demand for them from the user. Hence, the prefetcher acts as an allocator of data from the hard drive into the main memory before any actual request for it has been made. Okay, here's a quick question for you. From the following, which one is the correct naming convention for prefetch file? Do you think it's A, executable name -hash.pf, or B, hash-executable name.pf, or C, executable name -hash.pft, or D, hash-executable name.pft? If you said A, you are correct. As we have analyzed, the name starts with the executable file name, followed by a hash, which is an 8-character hexadecimal hash of the path from which the executable was launched, and .pf is the file extension. The path to the configuration parameters of the prefetcher is hkey local machine, system, current control set, control, session manager, memory management, prefetch parameters. To configure the prefetcher, we must change the value of enable prefetcher, and to configure superfetch, we must do the same with enable superfetch. The value 3 enables prefetcher or superfetch for application startup and boot. 2 enables boot prefetching. 1 enables prefetcher or superfetch for application startup, and 0 disables prefetcher or superfetch. It can be deduced that cybercriminals can disable the prefetch and get rid of prefetch files effortlessly to remove traces of illegal activity, such as opening an application filled with child pornography on a regular basis or accessing copyrighted material without the relevant permissions. The only cost is the performance of the system. Windows XP, Vista, and Windows 7 perform application prefetching by default, while Windows 2003 and 2008 are capable of performing prefetching, but the feature is turned off by default. Also, every version of Windows following Windows XP does boot prefetching. Superfetch files begin with the prefix AG and end with the extension DB. The data that is written into superfetch files is collected by sysmain.dll, located in the system root under the system32 folder, and is a part of the service host process, also known as svchost.exe, which is located in the same directory. The DB files can be found in the directory system root under the prefetch folder, along with the other prefetch files. The metadata in prefetch files is very important to forensic analysts. In Windows XP, the 64-bit timestamp that indicates when the executable was last launched has an offset of hexadecimal 78 within the file, and the counter that identifies the number of times the executable has been launched is a 4-byte word value located at offset hexadecimal 90 or 144 bytes. On the other hand, the offset of the last run timestamp is hexadecimal 80 in the binary contents of the particular prefetch file, and the number of times opened counter is located at offset hexadecimal 98 in Windows Vista and Windows 7 systems. It's also possible to dig up more data from the metadata or a prefetch file. Inside the prefetch file, there is data revealing the volume from which the executable was started, and strings that show the path to the modules with the executable required to start. In addition to the importance of prefetch files, answering when a certain activity has occurred via the last execution time, where activity has taken place, how frequently it was performed via the counter that shows the number of times the executable has run, which increments by 1 on each launch, prefetch files may reveal obfuscated directories. For instance, let's say a prefetch executable has been executed 50 times. By examining the prefetch file, we can see the file path of the files that trigger this execution, which is located in a TrueCrypt volume. As TrueCrypt enables users to conceal directories, it's vital to examine the path enumerated in the prefetch files, as this may be a door towards a data source that would have not been otherwise identified. If the examiner didn't look at the path, they may have never identified the obfuscated directory with a path hidden with TrueCrypt, because the System32 directory is filled with programs that are in use by the operating system, and an ordinary person would have never checked its contents. To conclude this module, we can say that prefetch files are designed to boost the speed of the system. In computers, prefetching can be disabled and enabled as the user prefers, and each time the contents of prefetch file will reset. Besides their primary purpose, prefetch files are useful for forensic examiners because they can prove that an application was installed and started on a particular machine. They can pinpoint the time when it was opened and how many times it was opened. They can also reveal from which volume it ran and which modules the application loaded. Furthermore, prefetch files may also reveal any hidden or obfuscated directories, temporary, unauthorized, or any other abnormal accounts. They may expose any external storage devices, and they can identify if there was time stomping. Therefore, prefetch files help examiners answer the who, what, why, when, and where questions that surround any digital or non-digital investigation. That certainly means that their analysis is of utmost importance. Don't forget to check the references and supplementary material for more information on the Windows prefetch, and catch me in the next module where we will be studying the restore points in Windows, which is another of the Windows Forensic Essentials of great importance.